So just kind of listen through. If you want to write down the symbols, you can. But I'm going to print you out these two slides exactly as they are. Hopefully my handwriting's neat for you. But cost is the amount it takes to produce X units of a product. We use C of X to relate cost. The sales of a function. The sales are the amount of material needed. So that's the amount of the material needed. How many of you are there? 1, 2, 3. Okay. And then revenue. Revenue is the amount of money you make based on the number of units sold at the price they're sold. So revenue is R of X equals X times P of X. So sometimes you might be given P of X, which represents the price per unit, but not R of X. So you have to know how to construct R of X given the price per unit. This is a lowercase p. Uppercase P stands for profit. Profit equals revenue minus cost. Profit equals revenue minus cost. And demand is P of X. So anybody in econ, you've probably seen or used these types of terms in the past. Then we have average cost. So average cost is the cost per unit for X units. So that's when you divide. So average cost is dividing your cost divided by X. You're welcome. There you guys go. Welcome. Okay. So then all of the averages are all divided by X. So it's easy to remember. Average divide by X. Average divide by X. And then the next question or part of the vocab is marginal. In calculus and in the real world, the word marginal is derivative. So in calc, you see marginal, think derivative. In calc, when you see marginal, think derivative. So that's C prime X, R prime X, and P prime X. That's the rate of change of each of those functions. So the application of each of these functions is important in the real economical world because we like to look at, okay, what is the rate of change of my cost? This is when prices increase based on demand. So you might notice that, let's take for example those Xboxes and PlayStations. They got bought and then marked up on other websites because they were in high demand. The amount of PlayStations and Xboxes being sold by the larger companies didn't match the demand by the people. So hackers, so to speak, with computers of ordering them, were able to benefit from this and sell them at a marked up cost. So that's an example of how do you find your maximum profit. Maximum profit is the point at which the derivative of revenue equals the derivative of cost. Max profit is when marginal revenue equals marginal cost. That should make sense, right? If profit is revenue minus cost, maxes occur at the zeros of the derivative. So 0 equals R prime minus C prime, or you could just add over your C prime. So max profit occurs when the rate of change of revenue is equal to the rate of change of cost. Okay, so those ones I think I did actually have you copy down. Just that last one at the very bottom of the page. And average cost or the minimum average cost, because we want to minimize our cost. As a company, you want your cost to be brought down. If the average cost is a minimum, then the marginal cost will equal the average cost. So the minimum average cost will occur when the marginal cost equals the average cost. So I know I'm going to start an example and have like no time to finish it. So let's see if we can get through one example before that bell rings on me. So suppose that r of x is equal to 9x and c of x is equal to x cubed minus 6x squared plus 15x, where x represents thousands of units. Is there a production level that maximizes profit? So again, if I am trying to maximize profit, I need to find where the derivative of revenue equals the derivative of cost. To maximize profit, I'm setting the derivative of each of these equal. So the derivative of r of x is equal to 9. Derivative of cost is 3x squared minus 12x plus 15. So we know that if we have a quadratic, it has to be set equal to 0. So I'm going to subtract 9 from both sides. So 15 minus 9 is 6. What's kind of nice is I could divide everything by 3. But that also helps me to see that there are no factors of 2 that sum to -4. So this would be a quadratic formula. So 4 times 2 is 8. 16 minus 8 is 8. But the square root of 8 is actually 2 square roots of 2. So I could take 4 divided by 2, which is 2, plus or minus 2 square roots of 2 divided by 2, which is the square root of 2. And then again, that should make sense that we have 2 answers on a quadratic. So in order to find where it is maximized, you would need to determine where this function is maxed out. So just for the sake of time, I'm going to, there we go, put up my little sign chart, and max profit occurs at 2 minus square roots of 2. So we'll pick up with the remaining examples at the end of the day. If anybody didn't know, it's Brooke's birthday, so you can tell her happy birthday. I learned that in the hall this morning. Alright guys, I'll see you back here at the end of the day.